Hi, welcome to the instructor video of the Projectile Motion Range Finding Lab. This lab can be found on the AP Physics 1 Two-Dimensional Kinematics webpage at www.njctl.org. Please note that complementary angles should be either reviewed prior to the lab or written on the board during this lab. In Experiment 1, students are required to experimentally calculate the initial velocity of the marble. Students should shoot the marble directly upwards to eliminate the x-axis Newtonian forces acting upon the marble. Students should then measure the vertical displacement of the marble with respect to its initial shooting point. At least 3 trials and an average should be calculated in the student's data section to minimize experimental errors. To mathematically find the initial velocity of the marble, students should use the third kinematics equation. Students should note that the initial velocity of the marble is 0 meters per second, and the acceleration of the marble in the y direction is the magnitude of gravity, or negative 9.8 meters per second squared. This mathematical analysis should be seen in the proof section of their lab report. In Experiment 2, students will experimentally support the idea that complementary angles will result in the same horizontal displacement when shut off at an identical initial velocity and an initial starting point. The following 2 slides show mathematically why complementary angles have the same horizontal displacement. Students should include the following analysis in their lab report. If an object is released twice at complementary angles with identical initial velocities from an initial height of 0 meters, the horizontal displacement at both angles will be identical. This is because the value of sine theta times cos theta at complementary angles will be identical. See derivation part 11, but note that the initial height is 0 meters. If it's not, you have to take in consideration the other part of equation 11. As an example, sine of 30 degrees times cos of 30 degrees is equal to root 3 over 4. And sine of 60 degrees times cosine of 60 degrees is root 3 over 4. Please note, if an object is released twice at complementary angles with identical initial velocities from an initial height other than 0 meters, the horizontal displacement at both angles will not be identical. Please enjoy this quick demonstration of how to shoot a marble launcher. Please note, this is the most important slide of the presentation. Please use this slide as a grading rubric for the students' lab reports. After the reports are graded, review this slide with the students. At this time, please pause the video and read over this slide. Thank you for watching this video. Please like this video and subscribe to the New Jersey Center for Teaching and Learning. Have a great day.